Okay, so this in this fairly wordy words volumes problem, let's see how we can solve this. So the most important thing is you've got some hard pendants that are being created and a lot of information is given. Let's start with this one. What they're saying is there's 0.323 pounds, so I'll write down pounds per cubic inch, so 1 inch cubed. Per, of course, means divided by 1, right? And now you're also given the cost over here. Each heart uses 0.75 inch cubed, so you simply multiply by 0.75 inch cubed here. So of course the inch cubes cancel out and you got the weight of each copper heart pendant. So you've got this value 0.2323 times 0.75 pounds. Now the next step, and you can get rid of this part right now. Now the next thing is each heart uses 0.75 inches. So we've used this value. Now a copper costs $3.68 per pound. So you can multiply this by 3.68 and the pounds is in the bottom here, so you're going to write down per 1 pound, and so this pound cancels out with this. So now you're left with this times this value over here. So let's just write this down: 0.323 times 0.75 times 3.68. Now this is the cost in dollars of one pendant. Now you've got 24 pendants, so you're going to multiply this by 24, and so when you multiply these four numbers, you're going to get a value of around 2140, and you can check it in your calculator. That's the answer. Now it's your turn to solve this problem. What if the answer were 66.24? In that case, how many copper hearts would be needed? So if the answer were 66.24, then calculate how many copper hearts. Obviously it's not 24, it's going to be more than that. So comment your answers and let me know how many copper hearts are needed if the actual answer is 66.24. Remember, you want to use the same method: 0.75 times 0.323 times 3.68 times x, and that value is equal to 66.24. So that's the hint for you. Let's try to find the value of x. So the circumference of a ball is given. So of course, let's remember the formula for a circumference. It's 2 pi r, and 2 pi r is equal to 19.9 centimeters. So the first, of course, obvious thing to do is to find the radius, and then you can find the volume. So how do you do this? You divide by 2 pi on both sides, so this goes away and you left with 2 pi. So you're going to get 19.9 divided by 2 times 3.14. So when you plug this answer in the calculator, you're going to get 3.1688. Of course, the unit is centimeter, so you're going to have this value over here as your radius. So remember, this is a ball and the radius is equal to 3.1688. Now what's next? They're asking the volume of the ball. Of course, the volume is equal to 4 over 3 pi r cubed. So let's plug this value in here directly. You get 4 over 3 times pi is 3.14, and then you multiply it by r cubed. This is multiplication by r cubed, which is 3.1688. I'll just use 3.17, and then it's a cubed here, remember. So when you use all of these values, you're gonna get the answer of around 133, and so therefore choice 2 is the correct answer. Now you try to solve the same problem, but instead of 19.9, I'll give you another value for the circumference, and that value is 3.14. Remember, the hint is 3.14 is actually the value of pi approximately. So see if you can find the actual answer. It's not one of these answers, but try to find out what's the answer to the volume of this ball. Remember, the volume, you first do 2 pi r is equal to 3.14, then you find out the value of r, whatever it is, and then after that you're going to plug this value inside 4 over 3 pi r cubed to get your answer. You'll need a calculator for this, so wish you the best for this, and comment your answers and let's move on. So we are told that the cylindrical pool is filled with water, and then you've got this cube. So obviously it's a volume problem. And then what's the volume of this cylindrical pool? Of course, it's a cylinder, so the volume formula is pi r squared h. So r being the radius, in this case the diameter is 16, so of course the radius is going to be equal to 8. And then what's the height? This height is 4, but that's not all. What they're saying is this pool is filled to half a foot below the top. So until here, this is a half a foot. Let's say this is half over here. It's filled only until here, so it's kind of like this part here. All this part is filled and the top part is empty over here. So of course the height no longer is 4. You have to subtract the half, which is 0.5. So 4 minus half is 3.5. Now you got the radius as 3.5. So let's plug everything in. You got the volume as pi times r squared, which is 8 squared, and then the height is 3.5. So when you multiply this, you will get 703.36 feet cubed. And of course, this is the volume, but you're also given, they're asking you in gallons, and you're given 1 foot cubed is gallons. So remember, what you do here is you multiply by this ratio. You multiply it by 7.48 gallons divided by 1 foot cubed. So foot cubes canceled out, and then you got 703.36 multiplied by this number here, 7.48. And so the answer is going to be roughly 5264 gallons. And so therefore 3 is the correct answer. Now I got another problem for you. What if the volume is actually in gallons? Of course, the amount of gallons is 804 now. If it's 804, then the diameter, let's say, is no longer 16. How much would the diameter have to be if all of these other things is half foot, etc., all of this remains the same, but the gallons is now 804? So let me know, what do you think is the diameter of the cylindrical pool? Of course, this part, this is the radius. What's the diameter of this pool if the actual amount of gallons of water is 804? So comment your answers. So here, this is a little bit wordier, but actually not a very difficult problem. It's a volume problem, obviously, and you've got a triangular prism. So what is a triangular prism? And it's a right triangular prism on top of it. So a triangular prism looks like this. So you've got this part here, which is the kind of like the base, and then you've got the same thing at the top here. So you've got this part here. Remember, these are the tops and the bottoms, and then you connect them like this, so it looks like a prism here. So all these parts are connected here. This is the back part, right? And this is the right triangle here. So now you want to find out what's the answer to this. So let's see how we can solve this. So of course, the volume is equal to the base times height. What is the base? The base is this bottom part, also the top part, and that's the base, means the area of the base, right? And then this is the height here. So this is the base and this is the height. So let's try to evaluate this real quick. You've got 70 is equal to the base times the height, and the height of the prism is given to be 4 here. So this height is equal to 4. So let's just put base times 4. So of course the base is going to be equal to, you divide by 4 on both sides, you get 70 divided by 4. So when you calculate this, you're going to get the base area of the base is 17.5, whatever the unit is. So this is inches, so it's inches squared. So remember, the base is 17.5. That's the first step of the problem. Now we're going to find out we're going to look further into this base. So now we look at this particular base over here. Let's expand this a little bit. You've got this base, it's a right triangle here, of course. This is the right triangle part here. This is the 90 degrees, and the area is given to be 17.5. Also, you're given one of the legs is 5 inches. So let's say this leg over here is 5, and let's call this other leg, which is what they're asking, determine the other leg, this length L. Okay, so now what's the area of the base? It's 17.5, but also remember, the area is half base times height. So this, in this case, this is the 5 base here, and this is the length L over here. Now you just have to find L. How do you find L? You multiply 2 over here, you get 2 times 17.5 here. 2 times 17.5, which is 35, is equal to 5L, and you divide by 5 to get 35 over 5, which is equal to 7. And so 7 inches is the actual answer. It is the length of this particular base over here, this particular part here, this part. Now you try to solve this problem if the volume over here of the triangular prism is not 70 anymore, it's 280 inch cubed. So very easy problem. You don't even have to do much. Just look at the connection between 70 and 280 and try to find out what is the length. Or you can solve it fully. Remember, if you want to solve it fully, you want to find out what's the volume, then you want to find out what's the base. From here, you want to find out whatever this value is. You want to take half b times L and then find L, and the b is already given to you as 5. So either way, comment your answers and let's see if you can now find the length with this new volume of 280. I'll be waiting for your answers. All right, this looks like a very wordy problem. All of this information here, but remember, you just want to work with these figures, and they're asking who was served more ice cream, Sally or Mary. This is Sally here, this is Mary. So let's try to find this out real quick. You've got this cylinder here. So what's the volume of a cylinder? The volume is pi r squared h. Now what is this value here? It's given to be 4. This diameter is given to be 4, and this height is given to be 8. So let's just plug that in here. Pi is 3.14. Then you got r squared, which is, this is 4, so the radius is going to be equal to 4 divided by 2, which is 2. So you get 2 squared times 2 squared and times 8. So just keep multiplying this, and the answer that you're going to get is 100.5 3.53. Of course, the unit is centimeters, so you're going to write down centimeter cubed. Now let's look at Mary over here. This part over here is 7, this diameter. So the radius is going to be equal to 3.5. And then the height is 12.5. In case you're not able to see it, I'm writing it down again. So now what's the volume of a cone? Very easy. It's the same as the volume of a cylinder, but with a minor difference. It's pi r squared h, but with a one-third on top of it. So you're just going to write this as 1/3 3.14 times r, which is 3.5 squared, and then multiplied by 12.5. So when you evaluate this, the volume over here that Mary has, this is Sally, Mary is going to have a volume. When you evaluate it, you're going to get the answer of 160.35 centimeter cubed. So of course, who was served more ice cream, Mary or Sally? Of course, Mary was served more ice cream. So this is going to be your correct answer. Mary was served more ice cream. And determine and state how much more is served. Obviously, you just take the difference. So 160.35 minus 100.53 centimeter cubed. Just copying this over here, subtracting it. This is the subtraction, and when you subtract it, roughly is going to be 60 centimeter cubed. Remember, they're asking you the nearest cubic centimeter, how much more ice cream was served. So nearest cubic was 60 cubic centimeters, and so that's your answer. Now here's a nice problem for you. If Mary is served the same amount as Sally, this is of course Sally here, this is Mary here. If Mary is given the same amount of ice cream as Sally, then determine what would be the height. Of course, the height right now is 12.5, but you want to make this x and try to find out the value of x. Remember, this height is 8, this diameter is 4, this diameter is 7 here. So try to find the volume of x, which will make them both equal. Remember, the volume of this is pi r squared h. The volume of this guy is pi r squared h, but 1/3, and you're trying to find out h. You're given this, and this over here. So comment your answers. This is going to be a great problem for you to solve. Just set them equal to each other and then find the answer. Remember, also the pi's will cancel out. So I'll wait for your answers and let's move on. All right, so let's try to find out what is the volume of a pyramid over here. You're asked the volume of this pyramid, and how does a pyramid look like? So let's try to calculate. Let's try to draw it. You're going to have this part over here, which is the top, and then the bottom part is like a square part over here, and of course you're going to have this part connecting here. So you have these 4 pieces, and then you have a square over here at the bottom. Right now what they're saying is find the volume. So remember, the formula for a pyramid is going to be 1/3 the base times the height. What is the base? Is the bottom part. So let's see, they're giving us information about the base. It's a square base, first of all, and the sides are 197. So this is 197, this is 197. So this is the base over here, and now you want to find out 1/3 BH. So what's the height is also given. The height is 107. So let's just plug that in here. Very easy. So you just plug it in. You get volume is equal to, and this is the height 107 over here, is equal to 1/3 the base. So what's the area of the base here? The base area is 197 times 197, because that's the area of the square. The square is always the side times side, right? The same side times same side. So you're going to write down this value over here, 197 squared times the height, which is 107. So 1/3 197 squared times 107. You punch it in your calculator, and the answer you're going to get is 1384188. So this is the answer you're going to get, and so therefore 2 is the correct answer. Now it's your turn to find the height, for instance, of the pyramid. So remember, the pyramid is like this, and you want to find the height of the pyramid if the volume is given to be this choice over here. So of course you got the pyramid here. This is the back part of it. Now you want to find out what is the height of the pyramid. What is the height of the pyramid if the volume is 4152563. So find the height. The height is no longer 107. So comment your answers. What's the height? Remember, the hint is, it's very easy. This 4152 is 3 times this value. So that's the hint for you. See if you can quickly find out the answer to this question and comment it. Okay, let's try to solve this problem. This problem is actually very interesting. What you want to think about is this length here is given to be 10, in case you cannot see this, and then this length over here is given to be 3, in case you cannot see it, and then this length over here is given to be 12. Now you want to find out, and of course this is 3, and then this mini part over here, this thin part, is 3 inches. Now you want to find out what is the volume of all of this. So first you want to find out the volume. So remember, how do you do this problem? You want to split it into 2 parts. So let's split it like this. Let's split it this way. Let's try to think about this part here. Then you've got this part, and let's cut it into 2 slabs here. So you've got this piece over here. So you've got 10 and then you've got 3 here, and then you've got this 3 inches. But let's think about 3 inches. What is 3 inches? So remember, 12 inches is 1 foot. So 3 inches is 1/4 of it, right? So it's going to be 0.25 feet. So let's now try to understand what's this particular volume over here. Remember, the volume is always length times base times height, right? So you got 10 times 3 times 3 inches, but remember that's a different unit. You want to convert it to feet because everything is in feet. So 10 feet times 3 feet times 0.25. So it's 30 times 0.25. So that value is going to be equal to 7.50. That is only this part. Now let's try to look at this part. Okay, so this part, the volume of this part is 7.5. Now let's look at this part over here. So this part is going to be, it's not going to be 12 anymore. Remember that this part is 12, but you cut out this part, right? So this part is going to be 12 minus 3, which is just going to be 9. And then it's going to be the same kind of math here. You're going to have 3 over here, and then this is 3 inches over here. This is 3 inches over here, but 3 inches is again the same way. It's 0.25 feet. So all of these are in feet now: 9 feet, 3 feet, and 0.25. So of course, what's the volume? Volume is length times base times height. So you're going to get 9 times 3 times 0.25 feet cubed, and that value is going to be equal, you can punch in the calculator, you'll see, is 6.75 feet cubed. So this part is 7.5, and then this other part is 6.75. So when you add these two together, you're going to get 14.25 feet cubed. And so therefore the volume is 14.25 feet cubed. And the final thing you want to do is, what is the weight? So this is a very standard geometry thing. You might want to multiply it by the weight finally. So this is 44 pounds per cubic foot. So you're going to have 44 pounds like this per cubic foot. Per means divided by, right, 1 feet cubed. So this feet cancel out, and you just multiply this 14.25 times 44. You can ignore the 1 pounds, which gives you 627 pounds as your answer. And so therefore choice 1 is the correct answer. Now you try to solve another problem of this type. Remember, if this was originally 10, but what if this, instead of 10, this 10, it became 20. So this is no longer 10, it became 20. This is 20 now, and this is no longer 12, it became 24. This is no longer 3, it became 6, and this is no longer 3, it became 6. And then this height here, it remains the same. So remember, all the dimensions across changed, they doubled, but this depth over here, 3 inches, still remain the same. And remember, 3 inches is equal to 0.25 feet. Now you want to calculate that the same way. You want to think about how can you first cut it into this part, then try to find the length times base times height, then this, and then cut it, and then you got length times base times height. You add those two, you're going to get this value, and then you simply multiply by 44, and then you can see what's your answer and post that particular answer. Remember, this is going to be very helpful for you to practice a new type of problem this way, so you know that you know this problem well. Now in this problem, you're given this right triangle over here, and it's rotated continuously around MH. So if it's rotated continuously around MH, how do we find this? This part is rotated like this. So imagine this part is rotated here, so it's gonna almost form a circle. This part is rotated like this, and this part is rotated like this over here. And then you can imagine, if you join this, it looks like a cone. Let me redraw this cone over here like this. So when you redraw this cone over here, you'll see that this height over here is 5, because the height originally is 5 over here. This height is 5 over here, and then this is 5, and then this radius over here is 8. So really it's a cone with radius 8, and then height of 5. And then now they're asking you find the volume of this cone. So the volume of this cone is just 1 over 3 pi r squared h. Remember, don't forget 1 over 3 over here. So 1 over 3 times 3.14 times 8 squared times 5, and that's going to give you your answer, and the answer is going to be 335.08. But remember, they're asking you to determine to the nearest 10. So that's one more thing you want to remember. You round it to 1, and so this part over here is going to be 335.1 is going to be your answer. Now see if you can solve the same problem. It's rotated again over here, but instead of 8 over here, instead of 8, I'm changing this and making it 16. So whatever you had before 8 became 16, so it doubled. Now of course you've got the original answer already as 335.1. So can you guess by how much you have to multiply this to get to the new answer of this new volume. Remember, if this doubles, then what do you multiply this by to get the answer? Post your answers in the comments. All right, so we're given a rectangular prism with dimensions of these types: 2 feet, 1 foot, 18 inches, and then the baseball has 2.94 inches. So first thing you want to do is you want to convert these 2 feet and 1 feet to inches. So of course, 12 feet is 12 inches is 1 foot. So let's convert it. So if you have 2 feet, then it's going to be 24 inches. So basically, the dimensions of this box are 2 feet, but instead of that, I'm going to write down 24 inches because everything should be in inches here. 1 foot becomes 12 inches, and then of course 18 inches remains the same. So let's draw this rectangular prism, or this Amazon box, first. All right, so let's label this now. Let's say this is 24 inches here. So like, imagine if this is 24 inches, then how many of these baseballs would be fitting it? And of course, remember the it's not visible here very clearly, but the baseball's diameter is 2.94 inches. So imagine you have a baseball here, then you have another baseball here, another baseball here, another baseball here, and then the next one, it kind of falls off. It exceeds the 24 inches. So how can you find how many baseballs can you fit in here? Very easy. If each of these is 2.94, you're just simply going to write 24 divided by 2.94. So that gives you the value of 8.16, which when you simplify, you get 8. So in reality, you can have 8 balls in this direction like so. Now the next one, let's look at this next dimension here. Let's say this was 24, so let's make the other one 18. So let's say this is 18 in this direction. So how do you set these balls? You can say 1 2 3 4 5 6 blah blah blah, and then this falls off. So how do you find how many balls can fit in if each of these widths here is 2.94? Remember, the ball is going to be inside here like this, but you have to think about it as a square, right? Because it's a diameter. So you want to think about it as a box. It's almost like a package. So how do you do this? This is 18. You're going to do 18 divided by 2.94 here. 2.94, and that value 18 divided by 2.94 gives you 6.1, which you can round off to 6. So therefore in here you can have only 6 balls. The 7th ball is gonna fall off. So you have 8 balls in this direction, you have 6 balls. Now you want to find out how many balls you can fit in this particular direction here. So let's evaluate that. So here, this length over here is this particular part is 12 inches, because we already found this to be 12 inches. So remember, this is 24 in this direction, this is 18, and then now over here 12. You did the same logic here: 2.94, 2.94, 2.94, 2.94, 2.94, and then this will fall off over here. So how do you find this? You do 12 divided by 2.94, and that gives you 12 divided by 2.94 gives you 4.08. And this is equal to 4. So in this direction you have 8, in this direction you have 6, and in this direction you have 4. So of course the total number of balls is just going to be the multiplication of 8 times 6 times 4. So 8 times 6 times 4 is equal to, when you put in a calculator, it's going to be 192 balls. So therefore the maximum number of balls that can be packed in boxes is 192. Now you try this very similar problem, but I've changed the problem. Now instead of 2 feet, I'm going to double this and make it 4 feet. Instead of this second dimension 1 foot, I'm going to make it 2 feet. And this 18 inches over here, I'm going to make it 36 inches. So every single part, the box was this way, but now I've doubled it. So it basically got doubled. Now if it got doubled, then how many baseballs would you need? Remember, the earlier answer was 192. So the main question for you is, if the dimensions are doubled, then 192 times how much is going to give you the actual answer. Remember, you don't have to do the full math now. You just want to remember, if everything doubles in all directions, then what is the scale factor? So comment your answer below, and then I will see if you got the correct answer. All right, this is a very standard problem. You're given a square pyramid and you're asked to find its volume and then its mass. But the first thing is, what's a square pyramid? A square pyramid means that the base is a square, which means all these 4 sides have the same length, and then from here it's joining the top over here like so. All right, so the formula is extremely easy. The volume of a square pyramid, or any pyramid, is 1/3 base times height. What is base? Base is the area of this bottom part, and then the height is this height over here. In this case, the height is already given. The height of the pyramid is 10 centimeters, so we just write down 10 here, and then the base is 4, right? So you got, my bad, it's 4.5. So you got 4.5 here, 4.5 here. What's the area of the base? The area is equal to this 4.5 times 4.5, which is 4.5 squared. So that part, I can even write this as b because that's the base over here, the area of the base. So you got 4.5 squared here. Now you just simply substitute it. So you write down 1 over 3 4.5 squared times 10, and then of course everything is in centimeters, so you just write down centimeter cubed. So when you evaluate this answer, you're going to get 67.5 centimeter cubed. But remember, this is just volume. What actually is needed, is the mass. So to multiply this, you need to multiply this by the density, and it's very easy. You remember, you want to multiply it because the centimeter cubed is in the bottom, so it's going to cancel out. So the way you write this is 0.676 grams per centimeter cubed. The centimeter cubed cancels out, and when you multiply these two values, you're going to get 45.63 and grams over here. So that's your answer. But remember, they're asking you to round to the nearest tenth. So of course you can round it, you can make this 0, and so therefore 45.6 is your answer. Now here's a nice interesting problem for you. Remember, the volume of the mass of this particular pyramid is 45.6, but what would be the height of the pyramid? It's no longer 10. What would be this height if the volume, if the mass is now 136.9? So instead of 45.6, this became 136.9. And remember, the hint I'm giving you is this volume is 3 times more. This volume, which I'm asking you to find, is 3 times more than the original one. So what would be the height required to find it? Remember, the original height was 10. So that's an easy problem. You don't have to do all the math. Just think about it logically and then comment your answer. All right, this is a very straightforward problem. You want to find out the volume of the cone in terms of pi. So here, the cone, in case you're not able to see this, the slant height is 13 and this base over here is 10. This entire length, because this entire length is 10, this part is going to be 5. Now there's one important thing that's missing, and that is this height. So let's evaluate that height real quick. So I'm gonna draw this part over here, just replicating this right triangle over here from this part over here. So I'm just kind of redraw this over here. You've got 5 and you got 13. So how do you find this value? A. Of course, this is a right triangle. Remember, this is the important idea for a cone. You're going to use the Pisaac theorem. So you're going to write a squared plus 5 squared is equal to 13 squared. So therefore, you've got a squared plus 25. Here, a squared plus 25 is equal to 169. So this is an a squared here. You subtract 29 from both sides, 25 from both sides, and you get 144. So a squared is 144. And so a would be how much? Is the square root of 144, which is 12. In other words, 12 squared gives you 144. And so therefore, this height is equal to 12. Now it's easy. You've got this part. You can ignore the 13. It's not important anymore. You just want to know this length is 5, this radius is 5, and this height is 12. And remember, this is going to be basically a cone of this type here. And this part is over here connected. So what's the volume of this cone? It's 1 over 3 pi r squared h. The r is 5 here. So you'd write this down as 1 over 3 pi 5 squared times height, which was what we figured out as 12 over here, this 12. So you're going to write down 12. Now 3 times 1 and 3 times 4 gives you 4 over here. So, and 5 is 25. So you can write this as pi times 25 times 4. When you multiply these numbers here, you get 100 pi, which is your answer. Now here's a quick easy problem for you. Remember, the original problem here gave the volume as 100 pi. Now what if the volume were 400 pi, and if the slant height remained the same over here? Let's say the slant height remained the same, then what would be this particular length? How much would it be so that the volume became 400 pi? So try to find that answer. What is this radius in case the volume became 400 pi? Very easy to find out. Just try to think about what happens when you multiply. The scale factor is 4. So what would be the radius have to be for it to become 4 times the original volume? So comment your answers and see you soon. This is an easy problem. You just want to find out the volume of the solid hemisphere, which is basically the hemisphere is half the sphere. So, and remember, the radius is given here. In case you're not able to see this, it's 2.8 centimeters. So how do you solve this? The first thing is the volume of a sphere is 4 over 3 pi r cubed. So if it's a sphere, this radius should be input inside here. But remember, that's not all. It's a hemisphere, which means hemi is half, right? So you multiply this by half. Or you can even, instead of this, you can just put in 2 over 3 pi r cubed. Either way is fine, but the main idea is just replace this 2.8 inside here. So you're going to get 1/2 times 4 over 3 pi times 2.8 cubed, like so. Now, when you have this value here, when you evaluate it, the answer you're going to get is 45.9761. I just approximated it, centimeter cubed. Okay, this is the volume, but this is the volume of the clay required to make one pendant, but you need to make 100 pendants, so you just simply multiply this by 100. So what do you get when you multiply this by 100? The decimal moves here, so you get 4597.61, and this is the centimeter cubed amount of clay that is required, the clay that is required here. So this value, when you round it, you get 4598 centimeter cubed, and that is your answer. Now this is a good practice problem. I will simplify this problem. You want to have the same hemispherical pendant, but instead of having 2.8 centimeters, let's just make it 1 centimeter. So this is just 1 centimeter, and instead of having 100, let's make it 1,000 pendants. So remember, the volume is going to be 1/2 of the volume of the sphere, which is 4 over 3 pi r cubed. So try to plug in just r is equal to 1 and try to find this answer, and then multiply it by 1,000, and then see what answer you get. I want to see if you can do this problem, so comment your answers and let's move on. Let's try to solve this problem here. So this is basically a simple problem. You've got a cylinder, and you're given that the cylinder is 4 feet tall. So this is 4 feet tall, but then the diameter here is 12 inches. So if the diameter is 12 inches, then the radius is 6 inches. But remember, 6 inches, because 12 inches is equal to 1 foot, 6 inches is going to be equal to 0.5 foot, and that's very important because you want to keep the units the same. This is 4 feet over here, and this is 0.5 foot over here. Now you want to use the basic formula of the volume, which is pi r squared h. So let's just plug this in here. You've got pi times 0.5 squared times h, which is 4 over here from this side here. And now you can just simplify this. So you got 0.5 squared is 0.25, so you get pi times 0.25 times 4. 0.25 times 4 is actually 1, so this becomes 1, and the answer is just pi. Now this is the volume of one footing. Because you've got 10 footings, you just multiply it by 10, and so the answer is going to be 10 pi, which is roughly 3.14 times 10, which gives you 314 feet cubed. So I'm just going to write this as 314 feet cubed over here, and then the final step is going to be 314 feet cubed. You just are given 2/3 of a cubic foot is required for one bag. So one bag is makes 2/3 of a cubic foot. So if you multiply it, you're going to have feet cubed here, so that's incorrect. To get rid of the feet cubed, you simply going to divide it. So you divide by 2/3 feet cubed like this, and then feet cubes cancel, and then 314 divided by 2/3 are going to give you the answer of 48 bags. And so that's your answer. 48 bags are required to make all 10 footings. Now you try to solve this problem. Remember, 48 bags are required to make all of this information: 4 feet, 12 inches, and 10 footings. But what if instead of 10 footings, I have 100 footings? So this is 10 times a multiple of 10. And then also, instead of 4 feet, I don't have 4 feet. I'm going to make this 8 feet here. So this became 8, and this became 100. So what would you multiply 4 bags by? What is that number you would multiply, and what would be the final answer to this? So how many bags would you have if instead of 10 you've got 100 footings, and then you, instead of 4 feet, you now have 8 feet? So very simple problem, but I think it'll help you understand this better. So post your answers in the comments, and I wish you the best.